Lesson is on evaluating polynomial functions. So your essential question is, how do I tell if an expression is a polynomial function? So first, let's look at the definition of a polynomial function. It's a function with multiple terms where all of the exponents in the expression are whole numbers. So you can't have any fractions. Remember, whole numbers are only 0 and positive numbers, so you cannot have any negative numbers. So for example, this function, f of x equals 2x squared plus 6x plus 5, that would be a polynomial function because all of the exponents are whole numbers. Now the leading coefficient is the number in the very front of the function when it's written in standard form. So when it's in standard form, it looks just like this example up here where we have it in descending order. So the highest exponent starts first, and then we would have x to the first power, and then this one would not have a variable. So if it goes like that, from highest to lowest exponent, that is standard form. So the leading coefficient is the number in the very front. So in this example, the leading coefficient would be 2 because it's the number in the very front when it's written in standard form. So in this example right here, we have negative 7x cubed plus 25x squared minus 8. The leading coefficient would be negative 7 because it is in standard form. It starts with the highest exponent and works its way down, and it's in order. And so the number in the front would be negative 7. The degree is the highest exponent in the function, and it doesn't matter if this one's written in standard form because it's really easy to tell what the highest exponent is. So in this example, we have 3x cubed minus 6x to the 5th plus 2x minus 9, and this would be the highest exponent, so the degree is 5. Now, the degree and the leading coefficient are important for what we're going to do with graphing later, so you need to know what those things are. Now, here's a chart to help you tell what type of polynomial it is based on the degree. So if it had a degree of 0, something that would have a degree of 0 would just be a plain number. This would have a degree of 0 because there's no variable in it. So this is considered constant because it's just one number, so it's always the same. If it has a degree of 1, where it just has like x to the first power in it, then that would be linear because when I graph this function, it makes a line. If it has a degree of 2, which means it has x squared, then that would be quadratic. If it has x cubed, then that would be cubic. That one's pretty easy to remember. And then if it has x to the 4th power, it's called a quartic function. So the two that are kind of hard to remember are quadratic and quartic because they're very similar. So just make sure you practice the differences between those two. And the others should be pretty easy to remember. Now we have a few examples, and I want you to decide whether the function is a polynomial function. And if it is, we're going to make sure it's written in standard form, and we're going to state the degree, the type, and the leading coefficient. So the degree would be the highest exponent. The type would be one of these names, constant, linear, quadratic, cubic, or quartic. And then we're going to also identify the leading coefficient. So feel free to stop the video after you see the example and see if you can list them and get the right answers. So here's our function. We have h of x equals x to the 4th minus 1/4 x squared plus 3. So first we have to decide whether or not it's a polynomial function. So if you go back to our definition, the only criteria was that all of the exponents were whole numbers. So that means that they cannot be fractions or decimals, and they cannot be negative. So this would be a polynomial function. Then we're going to make sure it's written in standard form. And this one happens to already be written in standard form because it goes from the highest exponent and then it descends from there. And then we need to state the degree. So what would be the degree of this polynomial? The highest exponent would be a 4. So the degree would be 4, which means the type would be quartic. And then what number is the leading coefficient? What number is in the very front? And that would be a 1 because there's no number in front of x, so we count that as 1x. So those are our answers for the first one. Let's try another one. See how you guys do. Like I said, feel free to pause and see if you can get the answers. So we have g of x equals 7x minus the square root of 3 plus pi x squared. So first we need to decide if it's a polynomial function. So are all of the exponents whole numbers? Yes, we only have one exponent. It's a 2, so that works. Then we also need to write it in standard form. So standard form would be from the highest exponent to the lowest. So that would mean that pi x squared would have to come first. So, and then we would have 7x and then minus the square root of 3. Then we need to state the degree, which in this case would be 2 because that's the highest exponent. So then the type would be quadratic. And the leading coefficient would be the number in the very front, which is pi. We have one more example. And this one actually, if we look, 5x squared plus 3x to the negative first minus x would not be a polynomial function because not all of the exponents are whole numbers. We have that negative 1, and so that is not a whole number, so we can't use that. Okay, we're going to talk about the different types of substitution. The one that you guys are most familiar with that you should already know how to do is direct substitution. That's when you plug in the number for x or for whatever the variable you have, and you work it out. So we're going to evaluate f of x equals 2x to the fourth minus 5x cubed minus 4x plus 8 when x equals 3 using direct substitution. So we're just plugging in 3 for x and working it out. It's pretty simple. So any place you see an x, you're going to put parentheses and you're going to put a 3 in. So we have 2 times 3 to the fourth power minus 5 times 3 to the third power minus 4 times 3 plus 8. So remember, you have to follow order of operations. So you have to do 3 to the fourth power first. Now you can enter all of this into your scientific calculator as long as you use the parentheses. It will come out with the right answer. So you can go ahead and pause and try that now if you want. Or you can work it out by hand. So 3 to the fourth power would be 81. 3 to the third power would be 27. And then 4 times 3 is 12. So then if we work those out, 2 times 81 is 162. 5 times 27 is 135. Then we have 12 and 8, and we bring them all down. And when we add and subtract straight across, you should get 23 as the answer. So that's pretty easy. Now this one is my favorite. I just really like it. Synthetic substitution. This is a different method for substituting in a variable. I feel like it's easier to do mentally than direct substitution. So if you have something that you need to plug in really fast, then you can use synthetic and it works really, really fast mentally. So I like this one. So I kind of have the steps written out here. But basically, you're going to make kind of like a little box like this. And you're going to write the number that you're plugging in on the outside. So like in the last example, we were plugging in x equals 3. So you're going to write that number on the outside. And then you write the coefficients of f of x in order of descending exponents. So you're going to write 2, negative 5, negative 4, and 8. Now, if an exponent is missing, you have to plug in a 0 for that number. So, for example, if I had an example where it was like f of x equals 5x cubed plus 2x plus 1, you'll see that I'm missing the x squared. So I would have to plug in a 0 in the place of that. So you really have to pay attention with that. With synthetic, that's the only thing that's kind of tricky. So let's try an example of this. We're going to evaluate the same function, what I just did. And this should be when x equals 3 also. They have to tell you what to plug in. So we're going to do that same example. plugging in 3 for x. So we should end up with the same answer. So like I said, again, you set it up like this. Now the first thing that you do after you've written what you're plugging in and then you write the coefficients of x, for this one, and I noticed that now that I missed that, we skipped x squared on this one, so I did this wrong. I should have plugged in a 0 right here because it goes x to the 4th, x cubed, and then there's 0 x squareds, and then x, and then the plain number. So I actually should have plugged in a 0 right there. So if we come down here, this is how it should be set up. Okay, you bring down the first number, so we bring down the 2. Then what you do is you multiply the 2 by the number on the outside. So 2 times 3 would be 6, and you write that there. And then you add going up and down. So negative 5 plus 6 would be 1. And then you just keep repeating the process. So 1 times 3 would be 3. Then we add, so we get 3. Then 3 times 3 is 9. And then we add, so negative 4 plus 9 would be 5. Then we multiply. 5 times 3 is 15. And then we add, and we get 23. And so that is our answer when you plug in 3. So you'll notice it's the same thing we got when we plugged it in directly. So I like synthetic because I feel like it can be very fast, but you have to make sure that you don't make the same mistake I did, and you have to plug in a 0 if there's any exponents missing. Okay, let's try one more example of that just for practice. I've also written the steps on here, so if you want to include these in your notes, feel free to pause the video and write these down. So the first step was to bring down the first number, and then you multiply that number by the number on the outside. Then you add the numbers inside, and then you repeat. So those are the steps. So we'll do one more example here. So this time we're going to evaluate f of x equals x to the 4th plus 2x cubed plus 3x squared minus 7 using x equals negative 2 is what we're plugging in. Now we'll notice this time it goes 4, 3, 2, and then there's no just x to the first power, so we have to plug in a 0 for that. So when we set this up, we're going to have negative 2 on the outside, and then we have 1x to the 4th, then 2x cubed, then 3x squared, then we had 0x, and then negative 7. If this confuses you, you can write these next to it if it helps you. You can write x to the 4th, x cubed, x squared, x, and then the number. So if you want to do that to make sure that you didn't skip any, that's completely fine. So we're going to go ahead and do the process just like we did before. So you bring down the first number, so we have a 1. And then we take 1 times negative 2 would be negative 2. And then we add. Negative 2 plus 2 is 0. And then 0 times negative 2 would be 0. And then we add, so we get 3. 3 times negative 2 would be negative 6. And then we add. So 0 plus negative 6 is negative 6. And then negative 6 times negative 2 would be positive 12. And then we add, so we get 5. So you should get 5 when you plug it in. And if you want to check that, because you didn't know if you did it right, then you can plug it in directly and see. But you will come up with 5 as the same answer. So you just need to take time to go back and answer the essential question from the beginning and use that to help you write your summary in complete sentences.